Hello and welcome to the Unit 3 video. I'm going to show you some of the tools associated with making a drawing in Inventor. And I wanted to start on the Brightspace page because I have a template file at this address. It's just a template file that you can download and use in Inventor. And so we'll look at why and what it looks like, that sort of thing. So in Inventor, one of the things I usually do is I open the files that I want to make drawings of. And so in Unit 2, you made an axle and a plate, and then you downloaded a bearing. Because the bearing is a part number that you order, I don't want to see a drawing for it. It's not a part that you manufacture, and the part number is sufficient for me to get a specification sheet from the manufacturer. So don't waste any time. You don't waste time modeling it, and you don't waste time making a drawing for a part that someone else is going to make commercially available. So I have my part files open, and I'm going to go to File, and I can make a new drawing. Now, when you download or install rather Inventor, you'll have a set of Inventor templates. Now, in an extension video, I will show you how to modify your templates to add the CETA template if you so wish. This is not an ideal drawing format for us. It's a size D, which is bigger than we need. The default border has information we don't need, so I'm going to go ahead and close that. And what instead I suggest you do is if you open the CETA template file that you download, you can open an Inventor file, and I called it CETA template. So now this is a simple drawing. Wow, that's zoomed in. Here we go. Simple drawing file. It's got the simple border for title blocks, and we can do a save as, and I'm going to call this McGinnis Axle DWG. I'm going to give it a 2 because, oh, you know what? I think I can just save over it. So save over it. DWG is my shorthand for drawing. It allows me at a glance to know that that's the drawing for the part file. So now I have saved a copy of the template file as a new axle drawing, and I can reopen the template and make a plate drawing. This is certainly the simplest way to just use it as you go, and you do not have to view the extension video about templates if you don't wish. So I have my axle drawing set up. I'm going to put in a base view, and I'm going to choose the axle. It's defaulting to hidden lines visible. You can remove them or show shaded. And this is a really simple drawing, so I think there's room for 3:1. And I'm just going to go ahead and click OK. And there is my base drawing view. So now I'm going to add a projected view. And to be honest, I think this is, yeah, I think you could go either way with whether or not that's your front or your right view. And so I won't be picky with how you do it. You can use your projected tool up here or right click and add a projected view of this. I'm going to go ahead and add the circular view, and then I'm going to add the isometric view. You'll notice that the circular view is aligned, right? I can't put that just anywhere. The top view would also be aligned, but it's identical. Isometric can go anywhere in this quadrant. And if you right click and choose create, it puts the drawing views in. So now I notice that there are no hidden lines in my front view, which is what I expect. There is a hidden line here because of the way I set up my drawing views. Not ideal, but it's also not wrong. And then my isometric view should be shaded with edges and half as large as the front view. So I'm going to double click on this view, change it to shaded, and change the scale to 3:2 instead of 3:1. And there we go. Another thing I notice is that my title block filled in. So I have dynamically linked the template so that this is the part file name of your part. This is just your username. If your laptop has something funky there, I can show you how to fix it. But as long as it is some semblance of your name, I'm fine with it. Scale and date. So how do you fix your author? Let's see here. It should be in the author location here. And if that's not fixing it, we can look in the eye properties of the part file. Oh, and it looks like that's the one mine is linked to. I'm just going to put my initials here for a moment to save a few characters. And there we go, it's updated. Okay, so that's how you put drawing views in. That's how you double check your title block. Last thing is some annotations. You have an annotate piece of your ribbon up here, and circles get center marks. It also shows us that both circles are centered at the same spot because I can see that those are concentric. Circular features in their rectangular view get center lines. So I'm going to click these two and stretch that through. Now, I'm actually thinking there's another way to do it. This is a perpendicular, and so I think if I select these two, that would also give me a center line. Oh, I hit the wrong button. Sorry, a few of the keystrokes in Inventor are quite a bit different than SolidWorks. I'm still learning them. But there we go. Now we have a center line there. Finally, we have a couple of dimensions to add. I shouldn't say a couple. I have 1, 2, 3, 4 dimensions to add to fully dimension this part. And all of the dimensions go on the front view here. So I choose my dimension tool, and I want to know the overall length of the part. And this is very important. So ANSI has some standards for how far dimensions should be from the drawing view. 10 millimeters should be the first dimension, and then every 6 you can place another dimension. So I'm going to find the 10 millimeter spot. But I forgot that I need this dimension here, so I'm going to drag it out one spot. And then using dimension, I'll put this one out at the 10 millimeter spot. And then you can see that I don't have crisscrossing. It's easy to see my dimensions. I only have 2 decimal places, but we're going to 3D print these, so that's probably as much precision as I can expect from our 3D printer. I would be pretty surprised if you're getting thousandths place accuracy there. So I have my diameter here and my diameter there. And now let's take a look at what this looks like as a whole. We are done. So I'm going to go ahead and hit the save button and say yes to all. I have a couple of things that have changed. And the last thing I want to do is a save as, let's see, I want it as a PDF. Oh, export to PDF. Here we go. So I save it. And I'm going to go to my file location. And now I have, let's see here, McInnes Axle DWG, and it is a PDF copy of my drawing file. So when I create my deliverable, I'm going to include my axle drawing, and my PDF of the drawing. So I'm going to go ahead and zip those up right now as McInnes Axle Unit 3. Okay, so that's the first part of my deliverable. So now I'm going to do the same kind of thing with McInnes plate. So I'm going to make, I'm just going to go ahead and open my template, do a save as. I'm going to move a little bit fast here because I want you to play around with this a little bit. McInnes plate DWG. I'm going to throw in my plate file and project it. The top view and the right view here are identical, so I don't need both of them. Get an isometric view, right-click, create, and let's move things around. Okay, I noticed that this is small, so I can probably make it 2:1. And I have hidden lines visible. Oops, Zooming looks a little bit different here. So the hidden line's visible. And I think the last thing I want to play around with is how do I get a circular center mark or a centered pattern? So I'm going to click on this centered pattern here, and 1, 2, 3, 4. Oops, that's not quite how it works. Actually, I think I select the center first. Okay, so sometimes you have to read the instructions just a little bit more carefully. So there we go. We have the circular center mark, and I hit the escape button so I can do it one more time. So I turn it on. I select the center point, which is really here, right? So I'm just going to select the center circle. And then the outside circles in order. And create, right-click create. And now I can dimension the bolt hole circle. And that's really the goal here, is to both communicate that the holes are on a bolt hole circle, but also that that bolt hole circle has a known diameter. The last piece I wanted to show you here that is different than a standard dimension is that our hole note will be a little bit different than a dimension here, because I'm going to see diameter and depth. It appears that I got a little sloppy when I was putting this in and didn't tell it to just be through. 0.43 is further than the dimension of the part, right? So this is 1/4 inch ABS plastic, and so I can see that that's a through hole. Now again, oops, making sure that turn off the dimension tool, making sure that this sits at that standard ANSI space. Okay, I'm looking at the clock and realizing we've been 13 minutes here. So I'm going to finish up here by changing that part file, or not that part file, that view display style, and leaving the rest of this for you to dimension. So think about if you were going to make this out of a thick piece of cardboard, right? What would you need to know about this part that I haven't yet told you? And as you put your drawings together, your goal should always be, if I wanted to make a quick prototype of this out of cardboard, do I have enough information to do that with? If you think about it that way, you will do better with inserting enough dimensions. Also avoid adding extra dimensions. So for example, if I was to dimension the top here and the bottom here, right? That is too much. Clearly the top and the bottom edges are the same. That is an egregious example, but an example nonetheless. So don't add extra dimensions. If I was to dimension the distance between this hole and the center, that's actually an extra dimension because I know that they're at this bolt hole circle. Now, what's not extra, and what actually I'm a little bit surprised isn't in this hole note, right, is the quantity. So let's see what that looks like. There we go, the quantity note. And then the last piece I would want to put here in all caps is equal spacing. So just to be clear that those 4 holes are equally spaced around the circle. And I think that would be sufficient for that whole note. I could change this to read through. So know that as you do this, you can choose to modify a little bit. What should not be modified is, for example, the quantity note and the diameter. Those should be dynamically linked. Really, the through should be as well, but here we'll have a small exception. If you have more questions, go ahead and ask. We're at 15 minutes, so I think that's more than enough. And I look forward to seeing your zip file that has part files, drawing files, and PDFs related to your plate and axle drawings.